Number 1, 0 plus a is equal to a, meaning that it depends on a. Let's find out. If a is equal to 0, then this will be 0 plus 0, which is equal to 0. Then if a is equal to 1, then this will be 0 plus 1, giving us a 1, meaning that it depends on this value here. And therefore, the answer is A. The second one, 1 plus a is equal to 1. If a is equal to 0, then this will be 1 plus 0, giving us a 1. But if a is equal to 1, then this will be 1 plus 1 equal to 1. For those wondering why we have 1, is that in binary system there is only a 0 or a 1. Third one, a plus a is equal to a. If a is equal to 0, this will be 0 plus 0, giving us a 0. But if a is equal to 1, then 1 plus 1 shall get a 1. And that is how our answer is A, because whatever we have here or here is what we shall have there. The fourth one, a plus a complement is equal to 1. If a is 0, then this will be 0 plus 0 complement, which gives us 0 plus 1, since it's a complement. And 0 plus 1 gives us a 1. And that's why we are getting a 1. And function, looking at number 5, 0 times a is equal to 0. If a is 0, then 0 times 0 gives us a 0. If a is 1, 0 times 1 will still get a 0. And that's why our answer is a 0. The sixth, 1 times a is equal to a. If a is equal to 0, then this 1 times 0 is 0. If a is 1, then 1 times 1 is 1, implying that it depends on this a. Whatever you have is what answer is defined by the answer you get. It implies that the answer you get depends on the value you have right there. The seventh, a times a is equal to a. If a is 0, then 0 times 0 we get 0. If a is 1, then 1 times 1 we get 1. So whatever you have here is what you get here. The eighth, a times a complement. If we are equal to 0. If A is 0, then 0 times 0 complement, we get 0 times 1, which is still 0. If A is 1, 1 times 1 complement, we have 1 times 0, and this is still 0, and that's why we have our answer as 0. Note function, A complement of the complement is equal to A. So if A is 0, then 0 complement is equal to 1 complement, which is the same as 0. And if A is equal to 1, then 1 complement of complement is equal to 0 complement, which is the same as 1. So the answer you get here is the same input you have there. So that's why you are seeing the output is the same as the input. As for commutation, this is basically just a principle that states that changing the order of these inputs basically gives you the same answer. So be it addition, be it multiplication, the order doesn't matter. As for the association, it says the result out of the disorientation of the order of the inputs doesn't matter. So you can have this in the brackets, or you can have this in the brackets. The order doesn't matter. The same applies to this. This can be in the bracket or this. Distribution property, it states that multiplying the summation of a number is the same as multiplying each of the components of the products. The same applies for this. Let's prove this. A plus B, A plus C is equal to, if we open the brackets, it will be A times A multiplying this, plus A times C multiplying this, then plus B times A plus B times C. But remember, A times A is A, then plus SC plus BA plus BC. Let's bring out the A, the common term, A outside. It will be 1 plus C plus B plus BC. But remember, we said anything added to a 1 will remain a 1. So it will be A times 1 plus BC. And that is A plus BC as our output. The absorption, A plus AB is the same as, if we pull out the common term A, it will be 1 plus B. But anything added to a 1 is 1. So it is A times 1, which is A. This A plus B is equal to, when we open the brackets, it will be A times A plus A times B. A times A is A plus A, B. If we pull out the common term, A will be 1 plus B. Anything added to 1 is 1. So it will be A times 1, giving us an A. This is a relation of the disjunction or in relation to the conjunction and, or the or, sorry, the and the or. So that is how you relate the negation of these two Boolean algebra expressions. So this one is representing the or, and this one is representing the and. And then this relationship of this negation, this is the and this is the or negation. We shall need these expressions when we are designing the digital systems, because they will help us in simplifying the Boolean expressions and therefore simplifying the logic circuit.